Hi everyone, welcome to my classroom. What we're going to be talking about today is the most famous equation in the history of physics, namely that E is equal to mc squared, the energy mass equivalency. There is an incredibly common misconception about this equation that I would really like to address with this video. Now let's see, do you understand E is equal to mc squared?
Right, onto my digital blackboard. Let's have a look at this problem. We have a person weighing 60 kg, gets on a train that starts moving and eventually reaches a constant speed of 20 meters per second. Calculate the change in mass of the person. Initially, this looks like a pretty typical E is equal to delta mc squared problem. So what I'm going to do is write down the most famous equation in the history of physics. Let's just write this down. E is equal to delta mc squared. Perfect. Now, because we're looking for delta m, the change in mass, what I'm going to do is just rearrange for that. And we're going to get that delta m is equal to E divided by c squared. The change of energy of this person will essentially be the change in kinetic energy, assuming that they're not moving initially, then they accelerate up to 20 meters per second. Their change of energy will just be equal to a half mv squared. Then I'm going to divide that by the speed of light squared. Let's plug in all their numbers. So a half times the mass is 60 kg times the speed squared, which is 20 meters per second. Let's not forget that square. And we're going to divide by the speed of light squared, which is 3.0 times 10 to the power of 8, all of it squared. Now, if we input these numbers into a calculator, we are going to get 1.33 times 10 to the power of minus 13 kilograms.
So does that mean that when I get on a train, I am suddenly 1.33 times 10 to the power of minus 13 kilograms heavier? In order to answer that question, we must really ask, what is mass?
In order to answer the question, does mass increase when an object's energy increases, we really need to be careful by what mass do we mean exactly. Let's have a look at the concept of relativistic mass. The equation that we know, E is equal to mc squared, is actually just a special case of the relativistic equation, that E is equal to gamma mc squared, where gamma is the gamma factor equal to 1 over the square root of 1 minus v squared over c squared. So the mass in this case, in E is equal to mc squared, is just a special case for when this quantity gamma is equal to 1. And this only happens, let's write this down, or only occurs when the speed is equal to 0 with respect to the observer. This is where the idea of a rest mass essentially arises from. In relativity, as your energy increases, it is your gamma factor that increases. Notice that we can also answer the original question, does mass increase when an object's energy increases, as yes or no. Once again, we can say yes if by that we mean the relativistic mass. If we mean the gravitational mass, which is calculated using only the rest mass in, let's say, Newtonian gravity, the answer is a definite no. What do I mean by that? Imagine that we have the Earth over here. Please take a moment to appreciate my drawing of the Earth. Let's zoom in, and let's say that we have a solar particle that's been accelerated by the sun, pretty close to the speed of light, and it is flying past the Earth. Now, if it is flying past the Earth at near the speed of light, even though it's a tiny particle, the relativistic mass might start tending towards infinity. Now, does that mean that the gravitational force of this particle right over here will start tending towards infinity, and this arrow here will become really, really big and shift the Earth out of its orbit? The answer to that is a definite no. So once again, there is a clear distinction between relativistic mass and a gravitational mass. In fact, when our energy increases, it is once again the relativistic mass that increases. And if we had a scale at which we could measure the amount of kg that an object actually has, the answer to that will be no, the gravitational mass will remain exactly the same. Hopefully this clears out a very common E is equal to mc squared misconception. Thank you very much for watching, guys. If you have enjoyed this video, please give it a like, and I'll see you in the next video.